Morning, all of you. This is V.Srinivasa Reddy, Associate Professor of Mathematics, Government Degree College, Ramannapet. Today, I will talk on linear homogeneous differential equation of order n with the constant coefficients. How to solve linear homogeneous differential equation of order n with constant coefficients. So, an equation of the form ANX plus d power n y by dx power n plus an minus 1x d power n minus 1 y by dx power n minus 1 and so on a1x dy by dx plus a naught x y is equal to qx is called linear differential equation of order n, where a naught x, a1x, anx are continuous real functions on a common interval I and anx not equal. Suppose if right hand side the function qx equals 0, if qx equals 0, then the equation 1, suppose qx equals 0, then the equation 1 is called homogeneous linear differential equation of order n. Uh, how to solve? First, we see how to solve the how to find the solution of a homogeneous linear differential equation of order n with constant coefficient. Suppose if a naught, a1, a2, a are constants, and an not equal 0, then an dn over y by dn d power n y by dx power n an minus 1 d power n minus 1 y by dx power n minus 1 and so a1 dy by dx plus a naught y is equal to 0 is called linear differential equation of order n with the constant coefficients. How to solve this homogeneous linear differential equation with constant coefficients? First, let d capital D equal to d by dx. Therefore, this implies you can write d square equal to d square by dx square. D cube is the d cube by dx cube, and so on. D power n equal to d power n by dx power n. So, substitute these values in equation 1. We'll get, so this is a n d power 1 y, a n minus 1 d power n minus 1 y, and a1 dy and a naught y equals 0. So we can write this equation as an d power n, an minus 1 d power n minus 1 and so on a1 d plus a naught y equals 0. Now if you take the whole this equation as pd of y equals 0, where pd equal to a naught plus a1 d and so on a and d and to the power n minus d power n. So here pd of y equal to 0. So now auxiliary equation means so PD now given equation we can write a PD of y equals 0, where PD equal to what is the a n d power n, a n minus 1 d power n minus 1, a1 d plus a naught of y equals 0. So now Tm equals 0. Tm equals 0 is called auxiliary equation of given equation 1. This can be written as only AE. Auxiliary equation, I will write simply AE. So Tm equals 0 is called auxiliary equation of given equation 1. So Tm equals 0. That is an m power n, an minus 1 m power n minus 1, and so on a1 m plus a naught equals 0. So this is the it is a polynomial of degree n in m. It is a polynomial of degree. It is a polynomial of degree n. So we can solving this equation we get n roots. Can get n roots because it is of degree n. It is a polynomial in m of degree n. So first we have to find out how can we solve. First we have to find out the roots of this auxiliary equation. We'll get n roots, but the roots means different cases will get Sometimes we will get real roots and complex roots. First, suppose case one. Case one, suppose the roots of auxiliary equation all are distinct. So for first find the roots of the auxiliary equations. Case one, suppose the roots of all auxiliary equation all are distinct and real. All roots are real and distinct. Suppose that if m1, m2, mn are the roots of auxiliary equation 3, real and distinct, then general solution or solution is y is equal to c1 e power m1x plus c2 e power m2x and so on cn e power mnx. Here m1, m2, mn are distinct and real roots. For example, if I will give a simple example one. Um, if the roots of auxiliary equation are minus 2, 3, 5, then solution is y is equal to, here we observe here all roots are real and distinct. Therefore, y is equal to c1 e power minus 3x plus c2 e power 3x plus c3 e power 5x. And if the roots of auxiliary equation are minus 2, 2, here these two are real roots and distinct. Therefore, solution is simple. Y is equal to c1 e power minus 3x plus c2 e power 2x. So this is the case one. So if the roots of auxiliary equation all are distinct and real, then solution is y is equal to c1 e power m1x plus c2 e power m2x and cn e power mnx. So if the one root is real, or if the one root is real and repeated, one root is repeated, say k times repeated. Suppose m1 is equal to m2 equal to mk equal to m. So suppose the root is repeated k times, and the remaining roots mk plus 1, mk plus 1, mn are real and distinct. Suppose the root m is repeated k times, so the remaining roots are distinct and real, then solution is like this: y is equal to c1 plus c2x ck x power k minus 1 e power m mkx e power mkx. You can write here c1 plus c2x ck x power k minus 1 e power mkx and ck plus 1 e power mk plus 1x and so on cn e power mnx. For example, for example, For example, the roots of auxiliary equation are 2, 2, 2 and minus 3, 4. Here, 2 is repeated 3 times. So, we get that root is repeated 3 times and minus 3, minus 4 are distinct. So, the first solution is y is equal to c1 plus c2x, 3, c3x square e power 3x. Because 2 is repeated 3 times, that's why we have to write c1 plus c2x plus c3x square e power 2x. And minus 3, 4 are different. Can write already we have taken 3 arbitrars. Next one c4 e power minus 6 and c5 e power 4x. Here 2 is repeated 3 times. For example, like this. So if the roots of auxiliary equation are minus 2, minus 2, 3, 3, 3, minus 4, 5. Here minus 2 is repeated 2 times, 3 is repeated 2 times, and minus 4, minus 5 are distinct. Therefore, solution, because minus 2 is repeated 2 times, we will get c1 plus c2x e power minus 2x, and 3 is repeated 3 times, c3 plus c4x c5x square, because 3 times. So we have to get 3 constants. Already we have taken c1, c2. I will start from this c3 plus c4x c5x square equal 3x, because it is 3 times repeated. That's why I have written up to x square. It is 2 times repeated. I have written up to x. And again, minus 4 and 5 are distinct. Therefore, solution c4. These are distinct roots. c4 e power minus 4x, c5 e power 5x. For example, another example, we see the roots of auxiliary equation are minus 1, 2, 2, minus 3, 4. Then solution is y is equal to c1 plus c2x e power minus x, c3 plus c4x e power 2x, and plus c5 e power minus 3x plus c6 e power 4x. So this is the second case. Because suppose the roots are real, suppose some roots are repeated, we can write like this. See one problem. So for example, you see d cube y by dx cube plus 6 d square y by dx square plus 11 dy by dx plus 6y. This is the differential equation of food order 3 because third derivative is the highest derivative in the differential in this differential equation and with the constant coefficients. This is the third order differential equation with the constant coefficients. Just like d equal to capital D equal to d by dx, then automatically d square equal to d square by dx square and d cube equal to d cube by dx cube. So from this, you can write this can be written as d cube y plus 6d square y plus 11 dy plus 6y equal to 0. So uh, this can be written as d cube plus 6d square plus 11d plus 6 of y equals 0. So now we can write like this. This is the qx is 0. This is a linear differential equation with the constant coefficients. And pd of y equals 0. What is pd here? 2d cube plus 6d square plus 11d plus 6. D cube plus 6d square plus 11d plus 6. So first we have to find out the auxiliary. What is the auxiliary equation? Is a Pm equals 0. So Pm equals 0. If you write in place of D, M, so M cube, write in place of D, M cube plus 6m square plus 11m plus 6 equals 0. Now we have to, here it is a polynomial in M of degree 3. So we will get 3 roots. First we have to find out 3 roots. How can we find roots? 3 roots. First, find out by inspection, by observation or by inspection. For example, if you write m is equal to minus 1, what we will get? Minus 1 plus 6 minus 11 plus 6 equals 0. So we will get 0. That is m is equal to, for writing m is equal to minus 1, it will become 0. Therefore, m plus 1 is 0. We know that suppose fa equals 0, then um, okay, here substituting m is equal to minus 1, we'll get minus 1 plus 6 minus 11 plus 6 equals 0. So therefore, m is equal to minus 1 is the root of the equation. So whenever if you write fa equals 0, d m minus fa equals 0, then x minus c is the factor. Like this here, m is equal to f of minus 1 is 0. That's why m plus 1 is the factor. So you can find other roots by synthetic division. How can we find this? So right here minus 1. Or the first right here, what is the coefficient of m cube? 1. Coefficient of m square 6. Coefficient of m 11 and 6. So right here 1. This is coefficient of m cube. Coefficient of m square. Coefficient of m and coefficient of and constant. So first right here 0. 1 plus 0 is 1. Minus 1 into 1 minus 1. 6 minus 1 5. Minus 1 into 5 minus 5. 11 minus 5 6 minus 1 into 6 minus 6 6 6 minus 6 0. So okay, 156 here degree 3. So we start with m square. Here it is m cube. So we start with m square. This is 1 m square plus 5m plus 6. So this can be written as m plus 2 into m plus 3 because we can write 5m as 2m. Here 2 into 3 6. We can write m square plus 2m plus 3m plus 6. M into m plus 2 plus 3 into m plus 2. Therefore, m plus 2 into m plus 3. Therefore, roots are minus 1, minus 2, minus 3. Therefore, general solution is so here we observe it. All are distinct. All real numbers are distinct. Therefore, solution is y is equal to C1 e power minus x plus C2 e power minus 2x plus C3 e power minus 3x. C3 e power minus 6. So the first case is for roots are real and distinct. Just we can write simple. C1 e power minus 6 plus C2 e power minus 6 plus C3 e power minus 6. So here we are getting three roots. So we have to take three arbitrary constants. So we see another example. Interesting. Another example. Solve d cube minus d square minus d plus 1 of y. So comparing with the PD of y equals 0, where what is PD? D cube minus d square minus d plus 1 equals 0. What is the auxiliary equation? Auxiliary equation is a PM equals 0. Auxiliary equation is a PM equals 0. So writing d in place of d, m, m cube minus m square minus m plus 1. So by observation, if you write m is equal to 1, it will become 0. So m is equal to 1, or 1 minus 1 minus 1 plus 1 equals 0. So 1 minus 1 minus 1, 1. So if you write here 1, so here first write coefficient of m cube 1, m square minus 1, m coefficient minus 1, constant 1, right here 1 minus 1 minus 1. Write first 0, here 1. So adding these to 1, 1 into 1, 1, and minus 1 plus 1, 0. 1 into 0, 0. So minus 1. So minus 1 plus 0, minus 1. 1 into minus 1, minus 1, get 0. So here it is m cube. So we start with m square. 1 into m square with 0 m minus 1. It is m square minus 1. So this can be written as, can we write m minus 1 into m square minus 1 equals 0. So therefore, m minus 1 into m minus 1, m plus 1 equals 0. Therefore, general solution is y is equal to c1 plus c2x plus e into e power x plus c3 e power minus 6. Here, observation here, roots are equal, 1, 1. It is repeated 2 times. So it is repeated 2 times. So this can be written as c1 plus c2x e power x plus c3. This is distinct e power minus 6. Same thing. Similarly, we try it. Similarly, we try d cube y by dx cube minus d square y by dx cube minus 6 dy by dx. Here we will get the roots of 0 minus 2, 3. For this 1, 1 minus 2. We'll try it. All of them, these homework problems can do. Okay. See another problem. So solve d square y by dx minus 3 dy by dx plus 2y equals 0 with y equals 0, x equals 0 and dy by dx. So to solve this, if you take d is equal to d by dx, this is d square y, this is minus 3 dy plus 2y, taking common out y, we'll get, you can write this equation as d square minus 3d plus 2 of y equals 0. So pd of y equals 0. What is pd here? D square minus 3d plus 2. So auxiliary equation means Pm equals 0. That is right, just d equal to m. You write d equal to m, what happens? M square minus 3m plus 2 is 0. So what are the roots? This can be written as easily 1 into 2. M minus 1 into m minus 2 is 0. Because we see m into m square minus 2m minus m. So plus 2, minus 1 into minus 2. So this can be written as m minus 1 into m minus 2. Therefore, roots are m is equal to 1. These two are distinct, real and distinct. Solution is general solution is y is equal to c1 e power x plus c2 e power minus e power 2x. So again dy by dx. dy by dx equal to c1 e power x plus 2c2 e power 2x. Since we have to find the solution with the condition y equals 0, x equals 0, dy by dx. So since y equals 0 when x equals 0, so by 1, write x equals 0, y 0, x 0. If you write x equals 0, e power 0 is 1. So c1 plus c2 e power 0, 1. So c1 plus c2 0. And again, given y is equal to 0 and dy by dx equals 0. So dy by dx is 0. So writing x equals 0 here, 0, c1 e power 0, c1 plus 2 c2 equals 0. So from these two, we have to get 4 minus 3. Uh, 4 minus 3 will get the 4 minus 3. C1, C1 will be cancelled. 2 C2 minus C2, C2 equals 0. So 4 minus 3. So by 3, you can write C2 is 0, C1 equal to minus 2. Therefore, required solution is y is equal to 0 plus 0 because we are getting C1 0, C2 0, 0 plus 0. So therefore, y is equal to 0. So similarly, we can do this problem. 16 d square y by dx square plus 24 dy by dx plus 9y equals 0. So here, this is like 16 m. What is the auxiliary equation is here? 16 m square plus 24 m plus 9 equals 0. This can be written as, this is like a square plus b square plus 2ab. A square plus 2ab plus b square. This can be written as 4m plus 3 whole square. We get minus 3 by 4 minus 3 by 4. 2 times repeated. Let's see next problem. Another case 3. You see case 3. Suppose when we are solving auxiliary equation, we get complex roots also. Suppose one pair of complex roots. Suppose if the auxiliary equation has one pair of complex roots, say a plus or minus a. You know that where I square equal to minus 1. And M3, M4 are real and distinct. The general solution is so these two are one pair. That means a plus ib is one root, a minus ib is another root. So it is one pair of complex roots. You know that whenever a plus ib is a root, a minus ib is also root. So we can write y equal to e power ax into. So suppose it has one pair a plus or minus ib. We can write this e power ax c1 cos bx plus c2 sin bx. So all these are distinct, remaining are distinct. C3 we can write C3 e power m3x, Cn e power mnx. For example, if the roots are m is equal to 2 plus or minus 3 minus 2, 4, 5, the solution. Observe here, it is a one pair of complex roots. 2 plus or minus 3 is a one pair of complex roots. So we can write solution y is equal to e power 2x into c1 cos 3x plus c2 sin 3x. And again, all these are real and distinct. You can write C3 e power minus 3x plus C4 e power 4x plus C5 e power 5x. For example, it is one pair of complex roots, m plus or minus I. This can be written as in the form of a plus or minus ib. We'll get 0 plus or minus I and 3, 3. It is a 2 times repeated 3 and minus 4 is distinct. So solution is e power 0x c1 cos x. Here a in place of a. Suppose one pair of complex roots a plus or minus in place of a 0, in place of b 1. So I will write this y equal to e power 0x c1 cos x plus c2 sin x because b is 1. c1 cos bx plus c2 sin bx. b is 1. So 3 is the 2 times repeated. So already C1, C2. Next C3 plus C4x d power 3x. And minus 4 is the distinct. So we can write C5 e power minus 4. So here in this, for example, if m is equal to, and that means here one pair of complex roots, 0 plus or minus, and 3, 3 is repeated 2 times, and minus 4 is distinct. Solution is this is e power ax c1 cos bx plus c2 sin bx. In place of a equals 0, in place of b is 1. And this can be written as c3 plus c4x equal to c5 e power minus 4. So if the auxiliary equation has a two pair of, have a pair of complex roots twice or repeated twice, say a plus or minus ib, a plus or minus. That means a pair of complex roots repeated twice and the remaining are real distinct, then we can write solution. Here a plus or minus ip repeated twice. So this can be written as here totally 4 roots. One root is a plus ib, another a minus ib, and again a plus ib, a minus ib. So this can be written as e power ax into c1 plus c2x cos bx and plus c3 plus c4x sin bx and remaining are this thing. So this can be written as like this c5 e power m5x and so on cn e power mnx. For example, see m is equal to 2 plus or minus 3, 2 plus or minus 3, 1, 1 minus 2. Here you observe it. So complex roots 2 plus or minus 3 repeated twice. So 2 plus or minus 3, 2 plus or minus 3, and 1 repeated twice minus 2, 3. So the first solution is can we write e power 2x into c1 plus c2x cos 3x and c3 plus c4x sin 3x because 2 plus 3i is repeated twice. That's why I have written C1 plus C2x cos x, and here C3 plus C4x sin 3x. Because these are the four roots. One is a 2 plus 3i, 2 plus 3i, 2 minus 3i, 2 minus 3. So that's why you have to get four constants. And again, one repeated twice, it is real number. So you can write C5 plus C6x e power x. One is repeated twice. This can be written as C5 plus C6x e power x. And again, minus 2 and 3 are different. That's why you can write normally by case 1 C7 e power minus 2x plus C6 e power 3x. This is the fourth case. So first case is all of this thing. Second case is some roots are repeated, real roots are repeated. Third case is one pair of complex roots, and fourth case is suppose a pair of complex roots or a pair of complex roots or a pair of complex repeated twice. How can we solve? How can we solve? We have seen this. Okay. Today we have seen how to solve homogeneous linear differential with constant coefficients by four cases. Case one is the roots are real on the string, and the case two is some real roots are repeated, and case three is it has one pair of complex roots, and fourth case is uh, a pair of complex roots repeated twice. Okay, thank you. See you next class.